Okay, so I'm going to be working out a finite element method here. This is the 5th edition, and I'm going to work out this problem for you guys. We're going to be finding displacements and forces in here. So first thing we do is we look at the problem and we count our elements. This represents element 1. This represents element 2. Okay, so I know I have a 2 local element matrix here. Next thing we need to do is count our equations, right? I have a force here, I have 1, 2, 3. So I have 3 equations. So what does that mean? That means that I have a 3 by 3 matrix when I go work this guy out. So before I even start the problem, I know the size of this guy. Okay, so that's a pretty important first step. Next thing we need to do is we need to take our local element matrix, we need to add them up here to get our global element matrix. Okay, so we're going to go from our local to our global down here. Okay, so how do we do that? Well, first thing I need to do is I need to look at force 1 here. So we're going to be starting here, right? This is all represents force 1 right here, all of these. So we're going to start here. We're going to go like this. So the first value we put in our matrix is this K1. Okay, we're done with force 1. Let's move on to force 2. Right here. Force 2 is represented here and here. Now let's move on to this force 2. Now, force 3 is next, right? So now we're here. And then we'll finish this guy out. Okay, so if you notice here, there's a 0 here and 0 here. So go ahead and put in the zeros where there's missing places. Okay, so now we've successfully added up our global element matrix. This right here represents this entire system. Next thing we need to do is our boundary conditions. So what does that mean? Well, we look at this guy and we go, this is fixed to a wall. So he's 0 because he's a fixed end. So go ahead and put your values in there. Okay, we are done with our boundary conditions. Okay, so we left off on this guy, right? Well, next thing we need to do is zero out our columns. This represents force 1, that would represent this guy. So I'm gonna go ahead and I'm gonna work out force 1 for you guys. It'd be like this. Okay, so that's how you work out force 1. If you notice, this is the first step, right? Now, if I work out force 2, that's represented here, how would I do that? It would be like this. Okay, so you can see the first step is here, right? Well, this 0 is really distributed to this entire column, if you see that. So this 0 right here is multiplied by everything here. So that's what I did here. So, and that's kind of the idea of this, right? This guy represents this column, this guy represents this column, and this one represents this column. So you can kind of see the pattern there. Okay, next thing we need to do is we need to move our forces to the right hand side. So if you look up here, F1, I don't know that value. F2, I don't know what that is either. We know what F3 is. We have that. So here's the goal. We have to take our unknowns, which is F1 and F2, and we need to move it to the other side of the equation. So what we're trying to do in the end, we're trying to get all of our unknowns on this side and then have all of our known values over here. Okay, so let's take F1 and let's move it to the other side. Well, that's what I did right here, right? So I want to point out this negative right here. If I were to work out this force 1, this would be like this, right? It would look like this. Force 1 is equal to all this other stuff, like that. Okay, so all I did here is I moved it F1 to the other side of the equation, and that's why that negative's there, in case you're wondering about that. Now, we don't want any negatives in our answers, right? Because that'll give us a negative answer in the calculator. So let's go ahead and distribute that -1 out. So let's put it here. Okay, so we put it there, right? So remember, this represents this entire column, so we're good there. Now, what do we do next? We need to take our force 2 and move it over. So this guy needs to come over next. And that's exactly what I did here. So, same pattern, right? Now when I do this, I'm going to have to create an extra column here, right? Remember, this goes with this guy, right? This with this guy. He would go with him, and then this would be represented here. So same thing, we distribute our negative out. So okay, so we have this. And don't forget to put your 0 over here. Left off on this guy, right? So all of our unknowns are on the right hand side here, and all of our known values are here on the left. So what is F3? F3 is this guy. We know him. What is K1? K1 is right here. So we know that value. What is K2? K2 is the exact same. Okay. So we know everything over here on the left hand side. So I want to go ahead and work out this problem. So here's how we would do it. Okay, so that represents force 1. That's this guy. So if you condense it, you get this. Okay, let's work out force 2. That's this. Force 2 is represented right here. Okay, so we get this, right? Let's move on to force 3. That's represented here. Okay, so that gives us this entire thing. And if you notice, this is a typo right here. This F3 is supposed to be right here. So this right here is supposed to be negative 5,000, right?
Now there's a cage locked around my heart. I found a way to drop the keys when my failures would. Now my hands can't reach that far. I ain't made for rivalry. I can never take the world alone. I know that in my weakness I am strong.